The subject of this video is the fast and easy wireless LAN deployment made possible by the Extricom wireless LAN architecture. It's an important topic because high and recurring deployment charges are one of the most unpleasant surprises that customers of traditional microcell wireless LANs often have. The Extricom wireless LAN drastically reduces deployment costs, as we'll see in a moment. In the videos Why the Channel Blanket Works Better and the Challenges of 802.11n, I described Extricom's channel blanket architecture. In this video, I'm going to show just how easy it is to deploy it. Let's look at a standard office setting. To bring a large amount of bandwidth to the employees, we're going to deploy the Extricom wireless LAN with 3 channel blankets as shown in the following slide. Channel blanket 1 will be a 40 MHz wide 802.11 blanket running on channels 1 and 6 in the 2.4 GHz band. Channel blanket 2 will also be 40 MHz wide and also 802.11n, running on channels 36 and 40 in the 5 GHz band. And finally, channel blanket 3 will be for legacy users and will be run as 802.11bg on channel 11. Now let's go ahead and set this up. The first step is to use the Extricom deployment tool to figure out the optimal AP placement. The first thing I need to do is bring up a map of the floor in the deployment tool of the building that we want to plan out. So we'll call the map 4th floor wireless LAN deployment. The next thing I need to do is make sure that the map is properly scaled, and we'll use a door because we know that the doors are a standard 80 centimeters in width. You'll notice when I press OK that the scales on the horizontal and vertical axis have changed. Now the next step is to add an EXSW 1600 wireless LAN switch and start planning the channel blankets. Now we'll go radio by radio and set this up according to our plan. We wanted the first channel blanket to be running 802.11n on the 2.4 GHz band. Get the MCS to where we want it, set it at 40 MHz width, HT only, get the guard rate down to 400, and our error rate can be as high as 300 megabits per second. Second channel blanket, we said we wanted to be 802.11n on the 5 GHz band, and in all other respects this channel blanket will be identical to the first one. Finally, we'll set up the legacy channel blanket, which is by default already set as mixed BG. We have to adjust the channel because we've already used up the other 2.4 GHz channels, leaving us with channel 11. And we can up the error rate to 54 if we want. And the final thing we need to do here is disable the 4th radio, and now we click on OK, and we see that we have a picture of a switch here which we can position. The next step is to add the APs, and we'll assume that at least at first that we'll try with 3 APs to cover the floor, and we'll position the APs at 5 meters from the left side of our map, and also at 20 meters and at 35 meters. In fact, actually at this point I'll use this opportunity to zoom out so we can take a look at the whole floor. Okay. Now we're ready to take a look at our expected coverage. Clicking on a single blanket heat map presentation and then clicking on one of the radials will bring up a heat map, which will give us an indication of how we're doing. And I'm going to use the 5 GHz 802.11n channel blanket for our first check. And we can see that our coverage is pretty good. The colors in the display are actually according to this legend below, and our coverage is pretty good, but it looks like we could do even better if we want. So what I'm going to do is add an additional AP, and what I'll do now is redistribute the APs to take into account the fourth AP that I've added, and we'll leave that one where it is, and maybe we'll position the other ones just a bit closer together. Put that one at 15 meters. Put the third one at 25, and the new one that we just added I'll put out at 45 meters. Actually, no, 35 meters is what I wanted to do actually. And you can see that we've got pretty good coverage on most of the floor. Actually, we can see that we've still got a couple of rooms which could be better, so what we can do is just quickly redo this again. We're going to move them down a bit now. And now we can see that we've got just about all of the floor covered with air rates, which are at least 180 megabits per second. So we can see that we have the floor covered with very good air rates. And in fact, even in the corners of some of the rooms, the worst case we have is 120 megabits per second, but in most cases we've got air rates of 180 megabits per second or better, which is quite acceptable for our office. Now we can check out the air rates at the 2.4 gigahertz 802.11n band, and we'll see that the coverage here is even better because the rate versus range relationship for the 2.4 gigahertz band is superior to 5 gigahertz, so we can see that the whole floor will get a 300 megabit per second air rate with the density of APs that I've configured here. So we're done actually, and what you can see is that I've achieved a very good coverage plan for this floor in just a few minutes. To cover the other floors in the building with Wi-Fi, all I need to do is duplicate the location of the APs on this floor. So at this point, all I would need to do is print out the AP locations and placing the APs physically according to what we've decided here. Now the reason why I was able to complete this part of the process so quickly is that with Extricom's channel blanket architecture, all one needs to do is evenly place enough APs around the office such that the air rates will be at the desired levels. There is no need to determine the best channel for each individual AP, nor is there a need to play with AP power settings, which are both complex challenges common to microcell based wireless LAN planning. So we avoid all of those complexities. And so the time savings at the planning stage for the Extricom deployment relative to microcell can literally be several man days, which translates into a savings of thousands of dollars. The next step in Extricom's simple deployment process is to go ahead and physically install the APs according to our results here, and then once that is done, the final step is to configure the switch, which, as I'll show next, is also a quick and straightforward process.